Okay, so the first sample problem is Dalton's law of partial pressure. All right, so let's use these just in case. Um, okay, so a gaseous mixture made from 6 grams of O2 and 9 grams of CH4 is placed in a 15.0 liter vessel at 0 degrees Celsius. What is the partial pressure of each gas, and what is the total pressure in the vessel? So, what we are looking for is we are looking for the pressure of the O2. We are looking for the pressure of the CH4, and we are looking for the pressure total. Okay, everybody good with that part? Okay. Now, let's look and see what we have. So we have a mass of O2. We have a mass of CH4. Okay, we've got a volume, and that's going to be the total volume, right? Because it's the thing that they put all of it into. So the total volume, 15 liters, and we've got a temperature, which there's really no total temperature. It's just that it is they're all at the same temp. So temperature of 0 degrees Celsius, which we're going to automatically turn into Kelvin. All right, everybody good so far? Questions? Okay. Now there are a couple of ways we can do this. Okay. But so if they just wanted the total pressure, the easiest way to do this would be to turn grams into moles for both of these, add the moles together, substitute it in using like this deal in the Pivnert, and then do the equation. Okay, but they've thrown us kind of a little bit of a loop here in that they want the individual pressures of each of the gases as well. So we're gonna have to do a little more work. Okay, now it doesn't really matter how we attack it. It doesn't matter if we find the pressure of one of these and the total and then subtract, or if we find the individual pressures of both of these and then add. I'm going to find the individual pressure of both of these, then add, but it really doesn't matter. So the first thing I'm going to do is convert grams to moles, because we need the moles to use Pivnert. So okay, and then we've got grams of CH4, and we're converting, what is that, 12 and 4, 16. All right. Yeah. Okay. So we've got the moles of each of these, right? Now, we're going to use the Pivnert, but we're going to use the one that looks like this, the pressure, like rearrange, like pressure equals nRT over V, like this. Okay, because we're solving for the pressure. So the first one, we're going to do the pressure of O2 is the number of moles of O2 times the R. Now, if we look at our R factors, or not. Well, okay, I'm not going to put it up here because I don't have one close to me, but I know what it is. It's the, so if you look at your R factors, the one we're going to want to use is the one with liters. And we don't have a pressure label, so we're going to use the one with liters. So that's the liters, atmospheres, or more moles, K. So that's the 0.08206. I think that's right, isn't that 8206? Okay, 0.8206. Okay. Liters, atmospheres over moles, K. And then our temperature is 273 K. And then this is all over our volume of 15.0 liters. Okay. So we do the math on this, and our pressure of O2 comes out to be 0.281 atmospheres, because atmospheres was what's left here. The liters cancel, the moles cancel, the Ks cancel. So our pressure of our O2 is 0.281. So everybody okay so far? Is it making sense following the info? All right, we're going to do the exact same thing with the CH4. Everything is going to stay the same. The only thing that's going to change is our moles. So pressure of the CH4 is going to be the moles of CH4, the 0.563, and then everything else, 0.08206 liters atmospheres over moles K, 273 K over 15.0 liters. And the pressure of the CH4 is 0.838 atmospheres. Okay, then all you need to do is the pressure total is going to be the addition of those two things. So 0.281 plus 0.838, which means your total pressure comes out to be 1.119 atmospheres. There we go. Okay, does that make sense going through it? Any questions?